Hi, I hope you are doing really well. Today we'll be going through the topic entropy. From this topic you can expect 4 to 6 marks. And actually this is a part of second law of thermodynamics. The reason I kept this topic a separate one because of its importance. In this subtopic we have concept of entropy, the interpretation of entropy, the principle of increase of entropy, entropy change for reversible and irreversible process, entropy generation or entropy production, combine first and second law of thermodynamics, TS diagram, entropy change equation for ideal gas processes, entropy change for solids and liquids, entropy change for open system, availability and reversibility, third law of thermodynamics. These are all the subtopics that is coming under this entropy, and here we will take it forward. Many students find this topic a bit challenging initially, but as they become familiar with the topic, they start to love entropy and questions related to entropy. Yes, it is interesting topic. At the same time, it will fetch you good marks in GATE and will form a solid base for coming topics. Later you will see topics like properties of pure substance, thermodynamic cycle and all. The subtopics entropy will form a strong foundation for these topics, and sometimes the questions used to come from a club to form. That means you'll be getting a question that is a single question will be there, and the concept will be both from entropy as well as properties of pure substance, or from cycles. If you are taking thermodynamic cycle, there also you will be finding entropy. So this topic is going to form a strong basis and it will fetch you good marks also. So that's why I already told you it's very important topic. These factors emphasize the importance of this concept of entropy both from exam point of view and concept point of view. Now let's go through the subtopics of entropy. We'll be elaborating how each topic is. Concept of entropy is very much related to Clausius inequality, which we have already seen from second law of thermodynamics. And entropy is given as dq by T is equal to change in entropy. That means change in entropy will be denoting with ds. D already you know that denotes a small change. So ds. S is the letter we usually denotes for entropy. So ds denotes change in entropy, small change in entropy, which is equal to dq by T. dq is nothing but heat transfer in that particular process, and temperature is the temperature at which that particular process happened. But this equation is applicable for only for reversible process. You will see that entropy change is a property change and entropy is a property, and we can prove this mathematically with a couple of steps. That's very easy thing. And so entropy is a property. So you know that property change will be same for both reversible process and irreversible process if its endpoints are same. That means consider there are two reversible, one irreversible and one irreversible process. Both are having same initial and final points. Then property change for these process, either it is volume change or pressure change or temperature change or even entropy change, will be same as its initial and final points are same, and because it's property. But you will come to know one thing, that's entropy change for irreversible process is not equal to dq by T. Confusing, right? But it is interesting fact. For reversible process, change in entropy is given by dq by T, and for irreversible process, same irreversible process, between the same initial and final points, entropy change is not equal to dq by T. But we already know entropy is a property, so it should be same for reversible and irreversible process. I know that we are really confused. That is the beauty. Once you understand this difference, you will start to love the subject. Yes, believe me, we are going to love this subject. And in our material, everything is explained properly, and you will fall in love with the subject. Later we will see entropy change of a system undergoing reversible process. Specifically we will be concentrating on different types of reversible process. Here we are having three subtopics. That means we will be adding heat, we will be taking heat, or sometimes there won't be any heat transfer at all, right? And they are reversible heat supply, reversible heat rejection, reversible adiabatic process. Here we are having three cases, right? And accordingly we will be getting some formulation or fun idea about how the entropy change is happening here. At this point, let me ask you a question. Not one question, actually two questions. Are you ready for this? Is all adiabatic processes are isentropic process? What do you feel? Now take the next question. Is all isentropic processes are adiabatic process? Think. You will find the answer. As you think, you may become an addict of thermodynamics, just like I became one. Now we will go through the physical meaning. I'll just give an example so that you will be having some idea. Earlier classes you might have heard about what is entropy. Entropy is nothing but a measure of randomness or disorderness, right? Here I'll give you an example. Consider that we are having two libraries, okay? In both libraries we are having huge number of books. Let it be 5 lakhs books in each library, okay? In first library or library A, all the books are arranged properly. So once you enter the library and you want to get thermodynamics by PK Nag, you have to just enter this name and the computer will point you in which shelf, in which rack, which number of book, in which place you can find that particular book, and you can easily go and get that book. Now consider library B. Here, even though we are having 5 lakhs books, nothing is in order. Everything is in a disordered manner. There is no computer to point out where we can find this book. So how long we will take to get one single book from this 5 lakhs books? It will be very difficult, right? Similar way the entropy is. More the entropy is, the less efficient will be that process, or the work extractability from that particular process will be very less. So the efficiency from that process of particular cycle will be very less, right? This shows the importance of entropy, right? Now the time to move on, that is entropy generation or entropy production. A new candidate, right? And this is having some peculiarity. This is not a property. In earlier cases we have seen that heat transfer and work transfer are path functions, right? But here entropy generation is also a path function. Yes, student, we are having third path function with us. So initial ones were heat transfer and work transfer. Now we are having one more, that is entropy generation. Now we are in a position to represent various processes on TS diagram. That means temperature entropy diagram. Temperature will be on y-axis and entropy will be on x-axis. You know how to represent various processes on PV diagram, right? We have seen that earlier. If it is a constant pressure process, it will be a line, right? Similar way, a constant volume process also. In a TS diagram, similar way, a isothermal process will be a horizontal line and isentropic process will be a vertical line. What about constant pressure process and constant volume process? How we can represent these processes on TS diagram? Or can you differentiate both of these processes from just by seeing the graph of TS? I mean, there will be two processes, there will be two curves in a TS diagram, and you will have to differentiate whether which one is constant pressure process, which one is constant volume process. Yes, it is really easy. Once you go through this material, you will fall in love with this and you can really differentiate each process carefully and with all accuracy. And this temperature entropy diagram is my favorite. Now we will go through the combined first and second law of thermodynamics. We will be combining both the laws. Earlier we have seen both the laws, right? Now we will combine both and we will be getting two equations. They are all called TDS equation. We are having TDS is equal to du plus PdV and TDS is equal to Th minus VdP. You will see how we arrive these equations and various applications of these equations. Now we are at one of the most important section as far as gate is concerned, that is entropy change for an ideal gas. That means here we will be having three equations for finding entropy change for an ideal gas undergoing a process. These equations will be relating either volume temperature or pressure and temperature or pressure and volume. So we are having three equations. I'll give you that equation. Delta S is equal to CV ln T2 by T1 plus R ln V2 by V1. And second one is Cp ln T2 by T1 minus R ln P2 by P1. And third one is Cv ln P2 by P1 plus Cp ln V2 by V1. I'm sure that if you're hearing this for the first time, you may get a bit confused. But believe me, it's easy. Once you write 2-3 times in a paper, you'll remember this equation. And many times, direct questions are coming that demands direct application of this formula. You'll be getting answer. You'll be getting 2 marks. Isn't that good? Okay. Now let me ask you one question. What is Cv? What is R? What is Cp? Cv is nothing but specific heat at constant volume. Cp is nothing but specific heat at constant pressure, and R is nothing but characteristic gas constant. Now we will move on to entropy change for solids and liquids. It's a direct equation. Delta S is given by mc ln Tf by Ti, that is mc ln T final by T initial, that is initial temperature and final temperature. Okay, fine. M is the mass of that particular liquid or solid. C is specific heat. For solids and liquids, we don't have separate Cv and Cp. It's only one, that is specific heat. Already gone through it in earlier classes, right? But so far, I did not tell you the most important section from this topic, that is principle of increase of entropy. If my guess is right, you can expect one question in this exam itself. Every time there is a possibility of getting this question. That's important is it can be either any statement questions or even problem question. Whatever it may be, it's very direct and easy question. And many times you'll find the application of this principle in other topics as well. According to this topic, it says that if any process to be feasible, the entropy change of the universe should be greater than or equal to 0. I'll repeat. For any process to be feasible, the entropy change of the universe should be greater than or equal to 0. Entropy change of universe is nothing but entropy change of system plus entropy change of surrounding. If this combined entropy change is greater than or equal to 0, we will say that that particular process is feasible. Right? If it is greater than 0, we will say that that is irreversible process. If it is equal to 0, we will say that that particular process is reversible process. What if the entropy change of universe is less than 0? That is nothing but an impossible process. So without doing the process itself, we can calculate, we can see whether that process is feasible or not, whether it is reversible or irreversible process. From entropy, this topic, a lot of varieties of questions can come. So it's important that you solve at least 50 different problems or questions from this topic so that you are in a friendly terms with entropy. Alright, next we will move on to availability and reversibility. This is a modern topic developed in order to conserve energy in maximum possible way or produce maximum work at minimum loss of energy. You know that 100% conversion of heat into work is not possible, right? But there is a maximum thing which we can convert, right? If it is a reversible process, we will be getting maximum result. You know that reversible process is not possible in practical way. So what is the maximum possible way of maximum possible extractable work from any system or process? That's what availability and this topic deals with. The number of questions from this topic is usually very less. The question, and even though questions come, this used to be straightforward also. Now we will go through the topic. Available energy, availability or exergy, all are nothing but same name of different name of same entity. All are same. This is nothing but the maximum possible work that can be obtained in a cycle or any process. That's what available energy, availability or exergy denotes. And you'll go through it and you'll be formulating some formula for different cases and for a cycle, for open system, for a closed system, so on. Then we are having Gibbs function, Helmholtz function. I'm not going into details of it. When you go through the material, you'll find this. Then we will go through the next important thing, that is irreversibility. There we'll learn Gauss-Todolo theorem and how it is related to availability and how it is related to actual and maximum process. Actual and irreversible process and all. Here we are going to really like this topic, irreversibility. I'm sure about this. Then you will learn about second law of efficiency. Even though the questions are easy to understand, even though the topic available energy reversibility is easy to understand, this topic requires your close involvement. Otherwise, you may miss some concept and later you may feel that you didn't understand this properly. So when a teacher is teaching this, pay close attention. I'm sure if any question coming from this topic, you can answer if you are paying full attention in the class. Finally, I'm to say the same thing again, that is, you may feel questions from entropy is a bit tricky if you are a beginner. I'm repeating, if you'll feel the questions from entropy as a bit tricky if you are a beginner. So a lot of practice is required for this topic. A lot in the sense, a lot comparing to previous topics. So a 10-hour practice on this topic should be sufficient, but it depends on person to person. Again, some persons will be require only 5 hours if he already knows the topic. If he is really intelligent, then also that much is required. But if you feel that you need more time to be spent on this, don't just be reluctant, just go and spend most of the time. It's not the intelligent who is going to win, it is the one who is more persistent who is going to win. Okay, bye. Now I'll give you some questions to warm up your brain, okay, so that you will be in a position to start the topic. It's not that I will be able to answer this question, but just think about this, okay? But these are all straightforward, easy questions. As you are not into this topic, you are about to start only, may not be able to answer, but you can think about it, okay? The question is, a system is changed from an initial equilibrium state to the final equilibrium state by two different processes. That means, I'll repeat, a system is changed from an initial equilibrium state to same final equilibrium state by two different processes. Initial and final states of two processes are same, and they're saying that one process is reversible and another process is irreversible. Which of the following is true whether delta S refers to the system? I'll repeat the question once again. A system is changed from a single initial equilibrium state to same final equilibrium state by two different processes, one reversible and the other irreversible. Which one of the following is true where delta S refers to the system? First option says delta S irreversible is equal to delta S reversible. Option B says delta S irreversible is greater than delta S reversible. Option C says delta S irreversible is less than delta S reversible. Option D says no decision is possible with respect to A, B or C. The question says initial and final state of two different processes are same, but one process is reversible and another process is irreversible. And they are asking question related to entropy change. They are asking us to compare the entropy change for these two processes. What do you feel? As we know that entropy change is nothing but a property change, or entropy is a property. So if the initial and final points are same, irrespective of the process, the property change should be same, right? So in this case, the entropy change will be same for both the process. So delta S reversible is equal to delta S irreversible. So option A is the right answer. Now take this equation, take this question. The equation delta S equal to R ln P1 by P2 determines the change in entropy of an ideal gas for a reversible process, which is, I'll repeat, the equation delta S is equal to R ln P1 by P2 determines the change in entropy of an ideal gas. See, the note that word ideal gas for a reversible process in which option A adiabatic, option B isothermal, option C isobaric, option D all of the above. This question says what process is this? From our earlier equation, that is entropy change for ideal gas, we are having three equations, right? And one of the equation was delta S equal to Cp ln T2 by T1 minus R ln P2 by P1. Okay, now for the second term I am taking the minus inside, so the equation will change to Cp ln T2 by T1 plus R ln P1 by P2. Here in the question we are having only the second term. The first term is going to be 0. When a ln term will become 0, ln1 is 0, right? That means ln t2 is equal to t2 is equal to t1. So ln t2 by t1 will become ln1. So that term is 0. t2 is equal to t1. That means that particular process is a reversible isothermal process. It's already given that it's a reversible process, so it is a isothermal process. So option B is the right answer. Okay, now one more question. If a system undergoes an irreversible adiabatic process, then I'll repeat, if a system undergoes irreversible adiabatic process, then option A, cyclic integral of dq by t is equal to 0 and delta S is greater than 0. Second option, cyclic integral of dq by t is equal to 0 and delta S is equal to 0. Option C, cyclic integral of dq by t is greater than 0 and delta S is equal to 0. Option D, cyclic integral of dq by t is less than 0 and delta S is less than 0. I'll repeat the question once. If a system undergoes an irreversible adiabatic process, note that irreversible adiabatic process. Okay, we know that for irreversible process, some cyclic integral of dq by t will be, what will be the value? And they say it's adiabatic process. Okay, I am not going to tell the answer for this. You find it yourself. All the best. Bye bye.